Alright, second part of our transformation section then is going to be about stretching and shrinking. We're going to have two types, vertical and horizontal, and essentially though they're pretty much the same thing. And then we're going to talk about the order of transformation, so you're going to want to write that down to make sure that we can keep our order clear, and that really just follows order of operations. So first thing, if we talk about a vertical stretch or shrink, it's going to affect your y-coordinate, which makes sense because we're talking vertically. It's going to stretch if C is greater than 1. So you're going to stretch by C units. Okay, it is going to shrink if C is in between 0 and 1. And so we can say that it shrinks by C units. Okay, and you notice that each time C is outside the parent. Okay, outside the parent function. Alright, so what you're going to do here is take your y-coordinate and multiply it by c. Think about it that way. It's going to go bigger by multiplying by c, or shrinking if we multiply by c and it's a fraction in between 0 and 1, or a fraction between 0 and 1. The other thing you want to avoid is that c always needs to be positive, no negatives. Okay, so the reason for that is because when we talked about negatives, that all had to do with reflection. So they're going to be two different pieces. An example, if this was actually negative 1/2, this would not only be a shrink because it's in between 0 and 1, but it would also be a reflection. So keep that in mind. When you have a negative number outside, it's a shrink and a reflection. We only want to look at it as a shrink right now. Okay, so here we have 1/2 is outside our parent function. Okay, so this is outside. If it was inside, it would be something like 1/2 x to the third. Okay, this would be a different type of stretch or shrink. It's not vertical like we're looking at right now. So this means we want to shrink everything. Now if I put some important points up here, we're going to say 1, 1 is a point and 2, 8 is a point. Okay, they match up for our function. So 1, 1 and 2, 8. And I put that other one in the wrong place. This should be down here, 2, 8. Okay, so we're going to shrink, and I'm going to write those coordinates into. We have, this is -2, -8, and -1, -1. This one is at 1, 1, and this one is at 2, 8. So remember what we said was to multiply the y value by whatever c is, so 1/2. So this 1, 1 is going to move down to 1, 1/2. This -1, -1 is going to move up to -1, 1/2. Okay, so those values are actually changed. The 1 at 2, 8, if we multiply our y value by 1/2, that will give us 4. So 2, 4 is where our new point is going to be. And 2, -8 is going to move to -2, -8 is going to move to -2, -4. Okay, now keep in mind that this is a drawn figure, so it doesn't look quite as good as it would if we graphed it on a calculator. And 0, 0 should stay exactly where it is. So our new function is actually going to be a little flatter like this. Okay, and it's not the best drawn thing in the world, but hopefully you get the idea. It's kind of like pushing the top and bottom together so that it's got to be shorter in height. Okay, a horizontal stretch or shrink is very similar. It's going to affect the x-coordinate though, which again makes sense because it's horizontal. If c is greater than 1 though, here what we need to be careful is now when c is greater than 1, it's shrunk by c units. Likewise, if c is in between 0 and 1, now you need to pay attention that it is stretched by c units. Okay, and what we do here, remember last time we multiplied the y value by this. Now we're going to divide the x-coordinate by c. So if I come to an absolute value graph, and again I'm going to do that same idea, I'm going to put some points up here. So we had a point at 1, 1. I'm going to pick some other random points. This is going to be at 6, 6. And then let's see, we can put a point at -2, 2. And how about a point at -8, 8. Okay, so this is 3, which means c is greater than 1, which means this is a shrink by 3 units. Okay, and we want to divide then all of those x values by 3. And let's see what happens here. So I'm going to take my negative 8, divide it by 3, and that is actually going to give me a point that moves. Negative 8 divided by 3 is going to be negative 2 and 2/3. Okay, if I take negative 2 divided by 3, I get negative 2/3. So you see the line is coming in much more. So this line, instead of being up, instead of being a little more shallow out here, is now going to be much more vertical. Likewise, if I take these points that I have over here, 6 divided by 3 is going to bring us into 2. And if I take my 1, 1 and divide that by 3, I'm going to be all the way in at 1/3. But you notice the y values didn't change, only the x values changed. And so it would look something like that. Okay, so we shrunk it horizontally, we squeezed it in. Hey, one other thing I would add about horizontal and vertical stretching and shrinking, they're actually the same thing. So if we look at this absolute value, another way you could write this, since 3 is positive, this would be the same thing as 3 absolute value of x, which now, since it was greater than 1 and outside, this would be a stretch vertically by 3, which makes sense because all of these points would be pulled up 3 units. Okay, so horizontal stretch and shrink is very similar, almost identical to vertical stretch and shrink. The last thing then we're going to talk about today is our order of transformations, and I said this is just like order of operations, so you want to think about working from the inside out. So the first thing you're going to do is horizontal shifting, then the next thing would be stretching or shrinking. Finally, next we're going to look at reflecting. So after we do our stretching and shrinking, we're going to either flip across the x-axis or the y-axis, and last thing is going to be our vertical stretching. Okay, so tomorrow we will finish up all of our transformations that we've done. We're going to talk about how these are the same or how to make them the same, so that really you only have to worry about doing one instead of doing both. Okay, that will be it. We'll see you next time.